Hey everyone, this is a new forecast for a new potential snow threat that we're looking at down the line. Um, I'm going to quickly show you some of the model runs, both the European model and the American GFS model. And let's start with the American model right here. This is the latest 6Z run. It was run a couple minutes ago, really. And notice right now that it's dusty outside, which makes a lot of sense based off what we're seeing in this current model run, and what we've been seeing for a while actually is that there was going to be, or is going to be, a trough that develops and actually dips down, as you see right here, right into the Italy-Greece area, and gets close to Israel. We thought like several days ago this could be a potential snow threat, which you saw me speak about, but it ended up being too far from Israel to really bring us any cold. But what it does do when the trough comes down like this is it brings up a lot of dust from the lower Egypt, Sahara Desert, the Negev even, because the winds are oriented at a southwest orientation. They're coming from the south and going to the west, and that brings up a lot of dry air, and we're going to see a lot of dust thanks to this setup that we have right here. And notice as the trough moves past us, Israel's right here, notice again, this is Europe. As the trough moves past us, we'll get into cold green air. It will be much colder, it might even rain, but it's going to be very dry air thanks to all the dust that's being pulled up right now because of this trough. And this trough pulls away, and notice that as the days continue, we're looking right now the 23rd of January, and then moving further, 106 days away from now, there's a new development of a trough that looks very promising for us, because basically what we see here is we've got a ridge developing over Europe. There's somewhat of a high pressure over here. We got a nice ridge being developed that's bringing down a trough, getting very close to Israel, much closer than the previous trough was. And as it continues to develop, it actually gets quite close to Israel, bringing us into the zone of potential for snow. We can even see 198 hours, excuse me, sorry, here we go, 204 hours. This is a long time from now. We're talking about the 26th, 27th of January, which is more than 7 days away. But at least we're seeing here a potential for a nice cold burst of air thanks to these ridges that continue to develop right over Europe. Ridges, I mean these shoots of warm air that come down and that create these troughs that come right to where we need them if we want snow here in Israel. The European model does something similar. Here we see the trough that we're currently experiencing now, bringing up all this dry air into Israel, and then it develops, forms, it actually gets cut off, which means that the ridge basically shoots right through the trough. It's called a ridge bridge. The cold air gets cut off, which means that it doesn't move as quickly. It's more isolated, and we do get a nice burst of cold air that actually comes down again 260 hours from now. But what we're seeing right now is potential specifically in these operational European model and American GFS model runs. And the reason why we're excited about this threat isn't necessarily because of what we're seeing on these operational runs that I'm showing you right now. These runs do show potential for a threat, but they're not showing anything major in terms of snowstorm. They're showing snow, but not big snow. But why are we excited about this? Has a lot more to do with what we call the ensemble members of the model runs. And what I've shown you are high resolution models. The European and the GFS operational run are high resolution models. And by high resolution, you can think of it as basically both models take a picture, thanks to all the data that's collected all across the world. They take a picture of the northern hemisphere, or of the really entire world. And just like a picture can have pixels, and the more pixels it has, the higher resolution it is, so too these computers, they take pictures of the whole entire Earth, and they can create these photos or these images of the world and predict what's going to happen with more pixels or more resolution, which means that they're taking in smaller amounts of land, analyzing that, and then another and another pixel of that land, creating a really large, detailed image of what the weather will do. This takes a lot of processing power, and these models are typically, only one high resolution operational models run, usually every 6 hours with the American model and every 12 hours with the European model. In order to see long range potential, we typically rely on what we call the ensemble members. And the ensemble members are lower resolution models, meaning they're taking bigger land spaces. They're analyzing greater chunks of land. By that I mean they're compiling greater chunks of land. So it's low resolution. It takes lower processing power. And these computer models are the ensemble members. There's 20 of them, and they're able to be all run at once. And you have, again, a picture of what's going to happen, but you have many different solutions, many different results. You have 20 because there's 20 of them, and they're lower resolution. But when we look at what all these 20 results are going to do, we can begin to see trends. We can see what might happen in the longer range. And let me just switch over to another image here. This might look complicated. I'm going to try my best to explain it. What we're seeing here are these lines represent the 20 different ensemble members. And we're looking at the 500 millibar temperatures, which was the map. We just looked at a 500 millibar map. We're just looking at data now on a graph instead of on a pretty map, and this is specifically for Jerusalem. So we get a very specific image of what the ensemble members are saying for our location. So it can be very useful to see this. We have 20 lines here, and the green line is the mean, the average of all these 20 lines. And we have the dates down here. This is January 18th. Notice how it progresses. And these ensemble members are predicting temperatures for the 500 millibar level, which is the highest level of the atmosphere that we like to observe, and for weather patterns. And in order for us to get snow, we typically need these lines to dip below -25. So here's -20, here's -30. Right in the middle is around -25. You can see specifically where the mouse is, what the line is at. And here's the range. The 26th or 27th is the range for which we're looking forward to snow. This is the biggest threat zone. When we looked at the trough before, we were looking at the date 26th through 27th. So if you look here, we're noticing a lot of the ensemble members take, I would say, everything below this area right here. There's a lot of ensemble members that go below -25, as you'll see, and they're all kind of consolidated between 2 days, really the 26th through the 28th. We got a lot going down. We got a couple going down to -30. We've got several going down to -28, and this is all pretty good cold temperatures for the 500 millibar level of the atmosphere, and it's showing that there's potential. What we would like to see as the ensemble members continue to update is that these lines become more consolidated, even more so, and we see them kind of all converge around one date. We're seeing right now that they're kind of converging around, again, the 26th through the 28th. And if the more encouraging map is at the 850 millibar. This is the lower level of the atmosphere. These are, again, the ensemble members. We're looking at the 26th through 28th, and notice how many go below zero. At the 850 millibar level, we definitely need temperatures to drop below zero in order to get snow. And we have pretty much more than half of these 20 these low resolution model runs called the ensembles going below zero between 26th through the 28th. Really kind of the 27th looks like the best zone, and this is a great consolidation, which means that they're really kind of converging around this time frame. They're all going below zero. A lot of them are going below zero, not everyone. These up here aren't. But the mean, notice how the mean goes below zero. That's a really good sign. Even though we're far out, we're literally looking at 7 to 8 days away from now. But with the ensembles, 20 models on average showing us going below zero at the 850 millibar level, which is the lower level. That's a really good sign that there's something cold and potentially snowy to come. And this is why we're getting excited about this threat, because we're seeing really good signal on these long-range ensemble members that something could be coming our way. And right now, the operational models, which were these maps, they're going to show, especially this far out, different solutions, different variations. There's not going to be that much consistency now. And we're seeing some solutions that show us great snow, a decent amount of cold with the GFS. The Euro could have been better. But I'll say that the Euro, the previous run, was actually really cold, brought a record-breaking amount of cold to Israel. And the previous run of the GFS as well looked much better. And there's going to be a lot of flip-flop between these operational runs on the high-resolution scale. But in the meantime, as the high-resolution models, as we get closer to the date, the high-resolution models will become more steady. But in the meantime, and by steady, I mean more consistent. We'll start to see them not have so much difference between each run. But in the meantime, we're going to keep looking at these ensemble members. This is why we're excited about this threat again. With the previous snow threat, we didn't see these ensemble members looking that great when it came to cold. We only saw near the very end that there was a potential for snow. Here we're seeing the potential very far out, and usually when we see potential very far out on these ensemble runs, that's resulted in accumulating snow for Jerusalem. I hope this made sense. It's very hard to explain on a quick video, and this isn't so quick, but how these ensembles work. If you have any questions, please ask. And I look forward to tracking this storm further the rest of the week. As we get closer, we'll have a lot more details. I'm feeling a lot more hopeful about this threat, though, than the previous ones. And it's exciting. Hopefully, we'll finally get something this winter. It will be very impressive if we do. That means we've had 5 winters in a row. Past 5 years of seeing accumulating snow in Jerusalem. That really breaks a lot of statistics. Usually Jerusalem gets snow once every 3 years. So I'm hopeful. We're in a good pattern for it. And again, if any questions about this video, if you have any, please ask in the comments. And look forward to speaking to you further. Have a good one.